Hello students, as we were revising our chapter 1 rational number, we have completed the first property of rational number, that is the closure property. Today we will discuss the another property, which is commutativity property, or we can say that it's a commutative property, and the associativity property. So let's start. In the commutative property, in the addition, the condition is a plus b is equal to b plus a. This is the required necessary condition. Means if you are adding a plus b, this should be equal to when you were add b plus a. Let's understand it by an example. Okay, suppose a is equal to 1 upon 2 and b is equal to 7 upon 2. Okay, first of all you add them. When you will add, you will get 8 by 2. Okay, you can cancel this also, but it is not required here. So 8 by 2, when you will add 1 by 2 plus 7 by 2, you will get 8 by 2. Okay, now change their position and then add them and check whether the answers are same or not. Okay, so when you will add 7 by 2 plus 1 by 2, this will be equal to 8 by 2, means both are equal. That means you can say that the addition is commutative for rational number. This is the required necessary conditions. You have to learn it. Now for the subtraction, also the condition will be same, only the sign will be different. A minus b, but it is not equal to b minus a. Learn all the necessary conditions. For the subtraction, a minus b is not equal to b minus a. Let's understand it by an example. Suppose a is equal to 3 by 5 and b is equal to 1 by 5. I am taking a simple example. When you will subtract it, you will get 2 upon 5. Okay, this is easy. When you will subtract, you will get 2 upon 5. Now change their position and subtract, means b minus a. What is the b? B means 1 by 5 and minus a is 3 by 5. Okay, so when you will subtract it, you will get 2 upon 5, and here in the numerator 1 is less than 3. 1 is less than 3 and the sign of 3 is here minus, that's why I am writing here minus 2 by 5. So you can clearly see that 2 by 5 is not equal to minus 2 by 5. The difference is of the sign. Here the 2 by 5 is with the plus sign and here 2 by 5 is with the minus sign. That means subtraction is not commutative for rational numbers. Next is for multiplication. A into b will equal to b into a. That means when you will multiply a into b, the same result you will get when you will multiply b into a. Let's take an example. Suppose a is equal to 7 by 8, multiply b is equal to 1 upon 3. When you will multiply, just multiply the numerators, you will get 7, and multiply the denominators, you will get 24. Okay. Now change their position and then multiply. B into a. This is b, so b into a. So here also when you will multiply, you will get 7 by 24 and both are same. That means multiplication is commutative for rational number. Now the last is for divide. A divide b is not equal to b divide a. That means from this line you can say that the divide is not commutative for rational number. Let's understand it by example. Suppose this is your a divide b. Okay, when you will solve it, when you will change the sign of the divide into multiply, this rational number will become reciprocal, means 1 upon 2 will be as it is. Multiply, this will become reciprocal, means 5 by 3. Now you just easily multiply it. Multiply the numerator, you will get 5, and multiply the denominator, you will get 6. Okay, means when you will solve this, you will get 5 by 6. Okay, now you solve b divide a. Take the same example and solve b divide a. This is b divide a. Okay, when you will change the sign of this divide into multiply, this will become reciprocal. 3 by 5, then multiply this 1 by 2 will become 2 by 1. Okay, Now easily just multiply them and you will get 6 upon 5. They both are not same. You can clearly see this is 5 by 6 and this is 6 by 5. Both are not same. That means you can say that divide is not commutative for rational number. So this was your commutativity or commutative property. Let's discuss the another property, which is associativity property. You can also say this is the associative property. Okay. So first of all, for the addition, associative property for the addition. This is the required necessary condition. When you will add a plus in the bracket b plus c, you will get the same result when you will add a plus b, and after that when you will add plus c in it. Remember, when you will add b plus c and in it when you will add a, you will get the same result when you will add a plus b together and after that plus c. Let's take a simple example. Suppose a is equal to 2, b is equal to 3 and c is equal to 4. So first of all, take the left hand side. This is your left hand side. Okay. Put all the values in it. A means 2, then plus, b means 3, then c means plus 4. So according to your BODMAS rule, first you have to solve the bracket. So first add them. This 2 plus will be as it is, and when you will add 3 plus 4, you will get 7. Now 2 plus 7 will give you 9. Okay. When you will solve the left hand side, you will get 9. Now solve the right hand side. First add a plus b, then whatever you will get, add plus c in it. Okay. A plus b means the value of a is 2, the value of b is 3. This will be in the one bracket, and then c means plus 4. Now you add the bracket. When you will add them, 2 plus 3 will give you 5, and after plus 4 will be as it is. Now add them, 5 plus 4 will give you 9. For both the right hand side and left hand side, the answers are same. You can clearly see the answers are same. That means the addition is associative for rational number. Now same for the subtraction. Addition and subtraction, all conditions are same, only the sign are different. And for the subtraction, the necessary condition is this, but they both are not equal. How? Let's check it. Take the same example. A is equal to 2, b is equal to 3 and c is equal to 4. Okay. So first solve this left hand side. When you will put all the values in it, you will get this line. In the place of a you write 2, in the place of b write 3, and in the place of c you write 4. Okay. According to BODMAS rule, first of all solve the bracket. So 2 minus will be as it is. 3 minus 4. 3 minus 4 will give you minus 1. Why? Because 3 is less than 4 and the sign of 4 is minus. That's why after the subtraction you will get minus 1. So in the place of this bracket you write minus 1. Now here is also a minus, here is also a minus. When you will open the bracket, this will become plus. Minus minus will always plus. Now when you will add 2 plus 1, you will get 3. Now solve the right hand side. A minus b in one bracket, then minus c is outside. When you will put all the values, you will get this. Now solve the bracket. 2 minus 3. When you will solve 2 minus 3, you will get minus 1. And then in the outside, minus 4 will be as it is. Now minus minus will become plus and sign will always be a minus. So this will become minus 5. So both are not same. You can see that both are not same. When you have solved the left hand side and right hand side, the answers are not same. That means subtraction are not associative for rational number. Next is for the multiplication, and this is your condition. Learn all the conditions because this is very useful when you will solve your exercise. Now take the same example. Put all the values in the left hand side first. Okay. First, this is your left hand side. When you will put all the values, you will get this in the place of a2, in the place of b3, and in the place of c4. Solve the bracket. 2 into 3 will give you 6 and into 4. And when you will multiply them, you will get 24. Now, when you will solve the right hand side, put all the values 2 into 3 into 4. First solve the bracket. 3 into 4, 2 into will be as it is. 3 into 4 will give you 12. And when you will multiply 2 into 12, it will give you 24. So, you can see that both are same. That means multiplication is associative for rational number. Now, last for the divide. This is your condition, but both are not equal. Okay. Now, put all the values in the left hand side. Suppose you will get this. I am taking the same example. Now, 2 divide 3 means 2 by 3. 2 divide 3 means we can write 2 by 3. And this is the divide. When you will convert this divide into multiply, this will become reciprocal, means 1 by 4. Now you can cancel this. By 2 you can cancel this, and here you will get 2. So when you will multiply, this 1 into 1 will give you 1 and 3 into 2 will give you 6. You will get 1 by 6. Now when you will solve the right hand side, put all the values in it. Now 2 divide will be as it is. 3 divide 4 can be written as 3 by 4. When you will convert this divide into multiply, this will become reciprocal, means 4 by 3. Now just multiply the numerators and multiply the denominators, means 8 by 3. That means divide is not associative for rational numbers. After that, few more properties are there. We will discuss it. Let's continue our property. The next property is distributivity property, or you can say distributive property. Okay, and what is the necessary condition? Two necessary conditions. This is the 1 and this is the 2. Okay, A in bracket B plus C. When you will solve this, you will get the same result when you solve A, B, multiply, when you will multiply A, B and then plus A into C. Learn all the necessary conditions. This is the one condition and this is the same condition, only the difference of the sign. Here is the plus and here is the minus. Okay, this is the next. Now, let's prove this condition. Let's take a simple example. A is equal to 2, B is equal to 3 and C is equal to 4. A, B, C, all three are a rational number. I have already explained you how. 2, 3, 4 all are a rational number. I am taking rational numbers only. Okay, so first of all, let's take the left hand side. This is your left hand side. This is your first condition and this is your second condition, and this is the left hand side of your first condition. Okay, put all the values. A is equal to 2 and B is equal to 3 and 4. So according to Bodmar's rule, first of all solve the bracket. So when you will add them, 3 plus 4, you will get 7. And here no sign is there, so we will consider a multiply sign. If no sign is given, so when the bracket will open, it will become a multiply. 2 multiplies 7. When you will multiply, you will get 14. Okay. Now check for this right hand side, AB plus AC. So put all the values. In the place of A put 2 and in the place of B you put 3, then plus in the place of A again 2 and in the place of C you put 4. When you will multiply 2 into 3 you will get 6, and when you will multiply 2 into 4 you will get 8, and when you will add them it will become 14. Means from here you can say that the RHS is equal to LHS. Means the condition is satisfied. Now check the next condition. First of all check for the left hand side, and here I am taking A is equal to 2, B is equal to 4 and C is equal to 3. You can take any rational numbers. Okay, I am taking a simple example. A is equal to 2, B is equal to 4 and C is equal to 3. Okay, put all the values in the left hand side. Now first of all, when you will solve the bracket, 4 minus 3 will give you 1 and 2 into 1 will give you 2. Now check for the right hand side. This is your right hand side. Now put all the values. In the place of A you put 2, in the place of B put 4, in the place of A again 2 and in the place of C again 3. Now multiply. 2 into 4 will give you 8. Minus will be as it is. 2 into 3 will give you 6, and when you will subtract you will get 2. Again you can see that RHS is equal to LHS. Means here also the condition is satisfied. So this was your distributive property. The next property is property of 0, or you can also say that this is the additive identity. Both names are same. Either you can call the property of 0 or the additive identity. And what is the condition? The condition is this, that when you will add 0 in any rational number, you will get the same rational number. If you are taking any rational number, suppose 1, 2, 3, any rational number you are taking, and when you will add 0 in it, you will get the same rational number. And this is the simple rule of the addition also, that if you will add 0 in any number, you will get the same number. This is the same rule for the additive identity. Suppose a is a rational number and I am taking 1 by 2 as my example. So when you will add 0 in 1 by 2, what you will get? You will get 1 by 2. Okay? And when you will add 0 plus 1 by 2, again you will get 1 by 2 only. That means either you add 0 from the left hand side or from the right hand side, you will get the number only. You will not get 0 or something else. You will get the same number. This was your additive identity. One more thing you have to remember, that 0 is the additive identity. If somebody asks to you that what is the additive identity, so 0 is the additive identity. Next is property of 1 or the multiplicative identity. 1 is the multiplicative identity, remember this. 0 is the additive identity and 1 is the multiplicative identity. Now what is the multiplicative identity? This is your condition. The same condition, that if you will take a rational number and when you will multiply 1 in it, you will get the same rational number. Suppose in the place of a I am taking 1 by 2. If you will multiply 1 by 2 into 1, what you will get? You will get 1 by 2. Okay? And if you will multiply 1 into 1 by 2, again you will get the same 1 by 2. That means from the right hand side or from the left hand side, if you will multiply 1 in any rational number, you will get the same rational number, and this is the multiplicative identity. 1 is the multiplicative identity, remember this. Next is additive inverse. This is the condition. Additive inverse means, what is the additive inverse of 2? The additive inverse of 2 will be minus 2. Why? Because when you will add the 2 and minus 2, you will get a 0. The additive identity means you have to take a number that when you will add the number in the first rational number, you will get a 0. Suppose I am saying that what is the additive identity of 9? What number you will add in it for getting your answer 0? Suppose I am adding minus 9 in it. So this plus and minus will become minus 9 minus 9. This will become 0. Means the additive identity of 9 will minus 9. Just take a simple fundament, that what is additive identity of 1? The additive inverse of 1 is minus 1. What is the additive inverse of 5? The additive inverse of 5 will be minus 5, because when you will add them, you will get a 0. But the additive inverse of 1 by 2 is minus 1 by 2, because when you will add them like that, when you will add them, either from the right hand side you add or from the left hand side you will add. Both the cases you will get 0. Next is multiplicative inverse. The multiplicative inverse means when you will multiply a rational number with the reciprocal of that rational number, you will get 1. Suppose, what is the multiplication of 1 by 2? The multiplication inverse of 1 by 2 will be 2. Why? Because when you will multiply 1 by 2 into 2, you will get 1. Suppose, what is the multiplication of 1 by 2? Multiplicative inverse. When you will multiply 1 by 2 into 2, you will get 1. That means the multiplicative inverse of 1 by 2 is 2. Or in the both cases you can say. The multiplicative inverse of 2 is minus 2. You can also say this. The multiplicative inverse of 9 by 8 will be 8 by 9. Because when you will multiply them, this will be cancelled and will give you 1. Means the multiplicative, this is the condition of multiplicative inverse. Whatever you are multiplying, whatever you are taking a rational number, you have to take the opposite of that rational number, and when you will multiply it, you will get a 0. So this was the property of rational number. Only one topic is there. That topic we will discuss in our next video. Thank you.